Hi guys. Sorry I was running a little bit late today, but we're gonna go ahead and get started here. Welcome to another Common Lisp Study Group, folks. Thanks a lot for joining us. We had a little bye week last week, primarily because of finals and schoolwork. I do apologize, but we're back in full stream for the summer. This week we'll be discussing packages and symbols following Chapter 21 of Practical Common Lisp. I decided after reminding myself exactly how this chapter was particularly structured to sort of take a step back and really discuss what packages are at a much deeper level than what the book really provides. But in order to really discuss that, we need to discuss a much more primitive thing that the book never really Practical Common Lisp specifically never really discussed, but it's discussed in pretty decent detail if you grab a copy of ANSI Common Lisp by Paul Graham, and that is symbols. So our agenda today is we're going to start with symbols because symbols are sort of the basis of how you end up bringing in packages, and it's actually what we use to define what a package actually is. And then, given time, I'll also touch a little bit on the different namespaces that Common Lisp provides outside of the standard functions and variable namespaces that we've all sort of become accustomed to either through our journey so far or from hearing a lot of people when they start talking about Lisp 1 versus Lisp 2. That's the first thing that they almost always hit has the differences. Functions and variables are in different namespaces, which means the same symbol could have both a function or same name could point to a function or a variable value in two different namespaces, which can cause confusion. But I'm jumping ahead of myself. I would like to thank and point out a couple of sources this discussion is going to be based on ahead of time. That is ANSI Common Lisp Chapter 8 on symbols. Of course, what we're covering in Practical Common Lisp Chapter 21. And this third article that I used, it's a bit outdated, but it really does come together when it comes to talking about how symbols work. I thought it was a pretty decent overview. That is Aaron Gatt's Complete Idiot's Guide to Packages, which is located at this URL. Now, folks who are watching the stream, if you want to actually grab the code and the notes for this discussion, all just like all other previous discussions, all the code and notes from previous CL study groups is available at github.com/atlantafp/CL studygroup.git. Go ahead, clone the repository, fork it, do whatever you want with it. It's available. It's open source. There are plenty of examples that came from the book. Some examples of my own. Just hack away with it. So I think we'll just get started here on starting with symbols. So what is a symbol exactly? So the way, if you read, Paul Graham especially, he defines symbols sort of like it is a built-in data type to represent names in CL is how he describes it. But I think that's sort of jumping the gun because it doesn't actually discuss what symbols actually try to solve. So to get into it, I'm going to talk a little bit about a little compiler terminology. So when you, in traditional compilers, right, and even interpreters, what you're typing into the REPL is a string that is going to be passed into the reader. And what the reader does is when it starts looking at the string, it checks it against a set of rules or productions that represents Lisp. And each piece of the string, particularly within the parentheses, dictates the start of an expression. And what Common Lisp does, and a lot of Lisps who use S expressions as its base representation for the language, it takes these individual values and constructs an object called a symbol. And that symbol basically is a binding from the first value, like in this case it's a plus, to a object that holds 5 different types of values. It's going to be the name of the value, which is plus, the actual value it is, and in this case, value and function, and that's these accessors here that I've listed. They represent 2 different namespaces. The value namespace is essentially if you set it to like a data type, a primitive data type, or another object inside the common Lisp object system. The function is as if you've actually mapped it to a lambda. I'll show you some examples later on this. But the point is when the reader actually translates this string into essentially a proper S expression object to hold in memory and to compile, it creates individual symbol objects to represent the function and its variables as well. So this would be a function and two values. Now, when you're inspecting this in your REPL, you will end up noticing very quickly that it goes through. It'll create the S expression, creates the objects, and then it will go through the evaluator. And the evaluator just runs with the symbol objects and then evaluates them. It essentially grabs, if it's a function, it looks up, what its arguments are. It'll grab the individual arguments, their values from their symbols, and then it hooks them together and then evaluates it. And in some cases, it will actually generate the assembly. Now, Common Lisp, since it's an interactive programming language, right? It's an interactive programming environment. It gives you the ability to actually define these symbols and inspect them and change them over time. So the symbol tables that are available to you are actually part of the results that the reader uses, but before the evaluator uses it, and it gives you the ability to go and change them in real time. So it gives you some flexibility to manipulate some of the values that you've actually inserted it as you developed your Common Lisp systems. Does that make sense? So I'm hearing no comments, so I'm just going to move on here. So these symbols are actually object instances. So they're just like any other Common Lisp object. They are essentially instances of an object. Particularly, they are instances of a def struct. And they do have these accessor methods. So you have symbol name, symbol value, symbol function, symbol package, and plist. So name is actually the string that you passed in, that parsed into it, and that got interned. Value is whether it's in the variable namespace, it'll be bound to this value. Function is if this symbol is bound to the function namespace, it'll give you the lambda, the anonymous lambda instance or function object instance that it's bound to. Package is the actual name of the string designator of the package that this symbol is a part of. So that's the symbol table that you really ultimately looked up to grab this object. And then you can attach additional attributes to the specific symbol that you can use later on. Especially, it will be kind of useful in some advanced like DSL programming techniques. So, though right now this is more of an introduction class, but we will visit that later on. So there are 2 types of symbols. There are intern symbols and uninterned symbols. Uninterned symbols are basically, so when a symbol gets created, it gets what's called internalized, and that's all that means is when you create a variable or create a symbol here, like using intern, what it does is in the current package that you're in, the current like namespace that you're in, it actually creates an entry in the symbol table, and it associates this name. In this case, we created test with a symbol object. So now if we go in, sorry about that. If we go in here and inspect this guy, you will see that that's actually unbound. I forgot about that. You'll see that there's an entry there, but since it's not bound to any particular value, it will actually spit out unbound, and it'll throw up an error in the REPL. Now, if I set this value, actually, because I can actually go ahead and do this, because it's already interned. Now, if I go in and try to inspect this guy,
that's a different.
Oh, it's a different symbol.
Object.
Yeah, I keep forgetting that. Hold on. That's right. When you notice that there is a difference. It's bound to the 3, but you notice that the difference is the quoted string actually got uppercased. All right. And the symbol instance created the name of that as being the uppercase version of the actual symbol that you passed in through as a quoted object, and then it actually goes and bounded it to 3. Now, one thing to note about this is, and this is why it's kind of interesting that it created that test value, but I think it's because I'm using something that's already been internalized in CL user called test. So let me pick something else here in a second. So now it created blah, all right? So this guy shouldn't be unbound too well, but...
When you access a symbol like that, you have to put the pipes around it, because it's gonna read what you type with a quote as uppercase.
So you're talking about, yeah, you're talking about when I pass it into slime inspect, right?
Yes.
Yeah. So it should be, I think, this way. Right. So the point that I was trying to make is that each of these are going to be individual symbols. So like if you want to create a lowercase based symbol, you can go ahead and do that. But normally when you pass in stuff into the reader, especially when you're defining a new function, or you're doing def parameter, what the reader does is it actually makes everything into uppercase, and then it passes it in. Now, there is a way of creating symbols with like the ones that is shown here, and I'll show 2 ways. One is using make symbol, and make symbol basically takes in a string and returns you a symbol that's uninterned. And the reason you know that it's uninterned is that there's a hashtag and a colon sign next to it. That's the reader's. I don't think it's a reader macro. I think it's a notation that's read in by the reader that basically says, okay, this is not to be interned. Now, this actually makes things a little bit interesting, because if you call make symbol twice, and I'll just take this guy here and copy it, and we pass in twice to equal, you'll see that it's actually generating 2 different symbols instances with the same name, and they're not equal to each other, so they're not actually pointing to the same object. So this shows you how symbols, first off, are real objects, or object construction. The way a symbol points to an object always is through internalizing that symbol inside some table that lookup, which we'll get to later. That's the basis of what we call packages, and you can also destroy symbols just like any other object in the environment. To get rid of an entry that's in a symbol table, all right, you can use what's called unintern, all right. Unintern, all it does is literally just going in to the symbol entry and deleting its entry. So I'm going to go ahead and, because I know that this is going to, both of these are actually bound. If we go and now try and do a find symbol on test, you will see, I think I have to pass in a string.
Yes, otherwise it's going to
Yeah.
automatically intern it and
Right.
find it.
No, Intern actually does that, right? Intern calls find symbols and then creates it if it doesn't exist. But find symbol just spits out that it's not of a type string. I think is what it does. So find symbol basically takes actually a couple of arguments. One is the name of the symbol that you're looking for, right? Two, it goes and looks at at a package name. So if you provide a different package that's not the current package that you're in, um, yeah, it will go look at it and return um, nil if it doesn't exist, or it returns some information about it. So one example would be like plus. I think, hold on, that's right. I have to do this. Keep forgetting. You'll see that if we look for the plus symbol, plus is a symbol. It's an and it returns two things. One is whether it's an inherited attribute. That means it comes from a package that's this current package is being used, or it's an internal attribute, meaning it's you've interned it in the current symbol table that you're looking at. So let's go through some examples to make this clear, right? So here I've already shown this to you. We use made symbol. We can also have spaces in our symbol when we do make symbol. You can intern a symbol, and what intern does is it uses find symbol to look if it exists, and if it doesn't exist, like it'll create one. So like as we saw here, we deleted this guy. So if we created right now, or if we do square, you'll see square doesn't exist. If we go in and intern it now, and we call square, you'll see now that square is now an internal symbol that has been defined. What's interesting about this is you can actually use this to actually define variables. Now, I don't recommend you doing this way. I'm just showing it to you to illustrate a point. You can use this same symbol object, which will do a lookup, and when you call it on this instance, because this quote and the name will create will notify symbol value that this is a symbol, does a lookup in the symbol table, grabs its object instance, and then just provides its value, just like objects, just like any normal object accessor. And that slot will give you the ability to manipulate that symbol object and define it. So here I'm using the same symbol for the sake of argument that and define it as both a function and a value. And this actually works. So if we call 2, you'll see that it's 4. If we call square, you'll see that it returns 4 because we defined it as 4. And we can also do square square, and it will go ahead and it'll know ahead of time. Okay, this symbol is both a value and a function, and we can actually see this when you actually. I think I have to do. Sorry, I have to do this. When we actually look at and inspect it, you see here we have its name square. It's bound to a value 4, but it's also bound to a function, which is defined in this file name. And it shows you what package that it's associated with, which you can also clearly look up if you do symbol package on square. So manipulating symbols and querying symbols are somewhat useful. Especially when it comes to reading and doing and they're the basis for binding functions and binding values and doing a lot of stuff related to DSL programming too. But in general, you will be interacting with it primarily through defining functions and defining values, and they are the basis for what we're going to be talking about next, which is packages. But one final point I want to point out is creating temporary symbols, which is, we've talked about this when we were talking about macros, that you wanted to use gensim to create new symbols. GenSym basically generates an uninterned symbol that the REPL can actually use inside code, and usually use this gen symbol when you're dealing with macros. You almost never want to have a predefined symbol or an interned symbol when you pass it in. But this actually creates the same objects that we were talking about before. They're just not in any specific table. They're not being managed by anything. Other types of symbols that are available other than temporary symbols and what we call user-defined symbols are keyword symbols. Keyword symbols are what it's anything with a colon in front of it. So if you have something called agenda, this guy, if you actually do type of, you'll see that it's actually a keyword. I'll show you an example about this later on here. But one thing to note is, for any given symbol, you have functions to check to see if it's bound. So if you're looking up in the value namespace, you're looking at bound p, and if you're looking in the function namespace, you have to call fbound p to see if the value exists or not. And of course, you can also unbind it. We're using mac unbound or fmac unbound, which allows you to essentially delete entries from that specific symbol itself. So if you go and now do a lookup on square, you'll see that it's unbound and it no longer has a function associated with it. Go back. And I've already discussed this, but just to reiterate, if you have two uninterned symbols, the one that we did earlier was with make symbol. If you also use this shorthand notation, saying that they are uninterned symbols, when the reader generates them, they will go ahead and create two new different symbols temporarily for that operation, and then essentially garbage collect them. Any questions so far? All right. So why did I?
Yeah, Bob, I have a couple points.
Okay.
You've gone through and you bound the symbol square to both a function and a value, and then ran, called square on square. And I've been goofing around in Slime, and just you might want to clarify that you can't. There are some things that you can type in that you can't bind functions or values to. For instance, if you try to set f the symbol value of plus, I think that was one of them.
Right. So that's actually, you're getting into something that that's actually a very good point, and that's part of this discussion about packages.
Okay.
So
right, I'll back.
Yeah. So you're ahead of the game there, but you made a very valid point. So what are packages? Okay. So this symbol name to symbol sort of relationship is the basis for packages, and by name I mean essentially a string, like any set of characters. Single character, whatever. This name to symbol relationship is a package. And specifically, formally defined, it's a collection of these name to symbol pairs, right? Within a given package, no two symbol instances, and I'm talking about symbol object instances, like in the object-oriented sense. No two instances will share the same name in the symbol in the package. Otherwise, you have what's called a name conflict, which we will discuss. This is very similar to modules or namespaces in programming languages such as C++ or Python, but I'm going to iterate that it's only on the symbols. Packages are a list of symbols, and and particularly when you read a package in, you are interning its symbols that are associated with its set of names. So as it's going through and compiling, it associates what name is to a newly constructed symbol, puts it in a table, and if another name while another symbol tries to use the same name, it'll complain and it'll tell you that there's a name conflict. Now, symbols are.
Yeah. Have we talked about read?
We've talked a little bit about read, but if you have anything to add about it, feel free.
Well, it's just read is intern is the thing that does this, but it's I think simpler to see with read. Like if you're at the REPL and you know
like read list plus.
Well,
two.
No, reads from standard input.
Okay.
So you can say read, hit enter, and then give some form. You know.
All right. So.
And it'll parse it, right?
It will parse it. Yeah, I actually talked a little bit about this when we were talking about symbols earlier. But to review, when essentially I associated with symbols almost like, well, the basis of symbols almost to like, the parser creating like a symbol table in like a normal, like if you're a compiled language. So that's essentially the analogy I went with. But if you have anything to add, Elijah, I mean, feel free.
No, that's very good. Part of the trick is, there's a current package, right? This is one thing I suppose we're going to be getting into in a little bit, but just say that there is a current package. We'll get into the details of that later. And the current package is that symbol table, right?
Right.
And so when you're loading in Common Lisp code, right, with the load function or whatever, it's being parsed using the exact same algorithm that the read function uses for parsing text, right?
Right.
And so if you, for example, say EQ and then 2 calls to read, right? Or EQL and then 2 calls to read and hit enter, and then type out the same name 2 times, you'll always get back T.
Right.
Right. It doesn't matter what name you use. It can be a name the reader's never seen before. But if you say, EQ, read, and you give the same name twice, you'll always get back the same object, is the point. The reader,
and that's
always,
right.
No matter what name you give it, will always give you not only something that's equal, but actually EQs, the same object. And that's useful for comparisons, and it's basically the foundation of how the symbol system works.
Right, and that's that's the very basis of packages as well, right? Because when you load in a package, because it's essentially a collection of name to symbol tables, it's going to go through in order for all the symbols that it visits, and if it hits the same symbol twice in the same code, that's in terms of a definition, it's going to go ahead and say, sorry, there's a name conflict here, or you're defining something that's already been defined. And I mean like defined using like defun or def parameter or def var, not like using set f.
No, the def parameter, set f, that has nothing to do with packaging, actually.
Really?
This is one of those interesting places where Common Lisp differs from a lot of other languages.
Okay.
Packages disappear after the parser.
After the parser, okay.
Yeah, after read, and read knows nothing about things like defun or def parameter. Read doesn't know anything about those. That's handled entirely by the evaluator. Read knows about the package system, and it's the only thing that knows about the package system.
So
all symbols.
Okay, so let me put it let me put it this way then. You're saying that when you use a def package and you export symbols, right? It will look through the export symbols, and it will create the symbol table based on the export list. And then, because we're going to be touching base on this, but this is definitely a good discussion that to bring it up.
Yeah.
It'll create the symbol table based on the export list, and then if it sees another package if it sees another symbol in an export list that it's already seen, it's going to complain, right? It's going to.
So, yeah, if a package can't have 2 different entries for one symbol.
Right, exactly.
This is correct.
And that's my point. And you'll see an example of this actually, because I think we should let me just go through this quickly, and we'll get to this example for further discussion. But
well, can I just try and wrap up?
Yeah, sure.
Little thing here. The point really is, and this is something that I think takes a little while to get used to, is that symbols really are objects, right? A symbol is an object, and it has a name, and it has a home package, and it has a value, and it has
A
a
function.
function associated with
Right.
it, right? And it has a p list. We may get to that someday. You don't need to know symbol p lists. We may have talked about them at some point. Anyway,
We haven't touched yet on symbol p lists, but like I said, I think that's something that we need to touch base on later on.
maybe you never need symbol p lists, and you should question yourself if you ever use them.
All right.
That's not quite true. There are some use cases, but it's a feature that hasn't been big in a long time. Anyway, so symbols really are objects, right? And I'm sorry if you'll give me just a moment. My laptop appears to be convinced it's running out of power.
So while Elijah is getting himself a power source, symbols, when a package is loaded, the symbols that it finds, particularly in the export list, as we were touching base on a little bit, those are what are actually, they're created entries into its package symbol table, okay? And there's two different types of like names associated with them, right? There's like when you're actually using names from that represents a symbol inside of a package. There's the notion of a qualified name and an unqualified name. When you do something internally, like that is in an actual package, you almost always, for the symbols that are defined in that package, use essentially an unqualified name, meaning that it doesn't contain a colon, doesn't represent. You're not like doing like if you're in foo and you define the function .bar, you're not always going to do foo : bar every time you use it within the same package. But if you're using a third-party library, and you would have there's two different types of way that you use functions within that package. One is a not recommended way, but I'm only bringing it up because a lot of existing code has this, and honestly, I don't know why, but some folks do this. You can either call a function or use a variable using a single colon, which refers to its external API, or you do the wrong thing and you use a double colon to refer to any symbol in the name package, essentially breaking sort of any sort of possibility of like cleaning up and adhering to the public API. And for new Lisp programmers, I do strongly encourage you, don't use double colon, please. Do not use double colon.
Double colon is weird, and it can have a lot of odd consequences that are.
The only thing worse than that is double colon %.
Yeah. Although that's convention more than. But yeah, you're right.
Convention and common Lisp, it doesn't stop you from really doing anything if you really want
to. Yeah, but just that only makes sense if you tell people that there's a convention that when a symbol starts with a %, it's something internal to the code.
Because it just, double colon, folks, basically is, if somebody has something that's private, right? And literally, it's private because it's not in the external interface of the, in the package. Don't use it. You can go and query in it, but the author hid it for a reason. Just because it's available in your image doesn't mean you have to go and use it.
Right. But anyway, back to sort of my whole point, right? Is that when you're past the reader, the name of a symbol only matters for printing.
Right.
When you're past the parser, the name of a symbol is no longer ever taken into account at all.
It's the symbol instant at that point.
Symbols are always compared using EQ.
Right.
They're always compared for pointer identity. Right.
Mm-hmm.
And this is important.
Right.
The evaluator, the Lisp runtime, doesn't know about the string names of symbols in the sense that the parser does. Just because two symbols have the same string name, right, doesn't mean anything. And actually, we touched on that earlier when you were creating uninterned symbols,
Right.
And actually, you can show this as well if you rerun that EQ example and you use the hash colon syntax, right?
Right.
That'll never return true. Is it? Well, no, just use read. Actually, use the call to read. I mean that works.
Right.
Yeah,
well.
sharp sign colon
Okay,
is
I got
good.
it. So you're saying foo. Okay. Right.
Right, and foo. That'll never return true because as Michael said, it always generates a new symbol.
Right.
And my point is that the name of the symbol is not what matters for most of the runtime, like at all. The name is not what matters. It's the pointer identity of the symbol is what matters for most of Common Lisp. The package system only exists as ways for you to reliably get access to a particular symbol object more than once. Right. That's the only reason the package system exists. It's a way of organizing all of these symbol objects we have into groups so that we can get to them quickly, repeatedly. Right. And it's not a way. I mean, you use it for declaring parts of your API, definitely.
Right.
But it's not a runtime construct in the sense of a lot of like namespacing systems in other languages, where a class has a namespace like you have in C++.
In C++,
like that.
the way that works, it's still a compile time construct. It generates the name-mangled name, right, at compile time when it generates the parse tree, right? And I think it's sort of the same. I wouldn't say it's the same thing here because the way the reader works, it creates a new symbol object instance that it points back to and grabs information when it needs to, which is very different in terms of its compilation strategy. If you really think about it, right? So they're similar but different. That's why I only say in terms of like if you really want to think about it as organizing lists of symbols, right? Rather than thinking about it as I'm binding a function to something and now it's always going to be this. That's not actually true.
The thing is you bind a value to a symbol.
Right.
Right? You don't bind it to its name.
You don't bind, and that's I actually tried to touch base on that a little bit later when I give some examples. But just to continue on this discussion, there is so there's different ways of accessing symbols, and we touched a little bit about this, but you can find it in a current package, and I will give you an example here. Like I have a package that I've defined much later on. Let's say that we have this package 1 that has 3 functions, all right? And in fact, I'm going to make it even simpler. Let's say that we have a package test here. And the way to define a package is you use def package. And we say that we're using CL. And I'm going to, folks who are watching this, there are a lot more options, but we'll touch base them as we go on. But just for the sake of example here, what I'm going to do is I'm going to define this package, and then I'm just going to go into it. Now, anything that's defined in this package, let's say that we define something like myAdd that adds 2 numbers. Normally, you don't have to. Now, so you can use the unqualified name here to actually access this function. And that is intern that's present in the current package. It's X. What it's doing is just doing a quick lookup in the current package. It finds the symbol object instance, and then evaluates it. Okay? You noticed in my def package example, my simple def package example, that I used Common Lisp. Use is actually a shorthand for use package. So I could have certainly, instead of saying use :CL here, say use package and grab all the symbols that are associated in Common Lisp's external API that's defined in the external what's called the export attribute of the def package form, those will get internalized and those will get entries in the current package symbol table. All right. Again, though, as with anything, we're only talking about one symbol at a time, and there is an example where I will show you where shadowing ends up messing things up, and you'll end up getting incorrect results. But the last thing is you can take sub pieces of symbols, some symbol instances, and import them. Only those symbols from one package to another, and I'll give you some examples there on that. But what a package only does, and this is what I'm trying. If this is what you get out of this, this is fantastic. It just only gives you very basic control on how the reader translates string names into symbol object instance. It doesn't give you any sort of like direct control over variable access or function access, because we're not at that stage yet when we're dealing with those kinds of issues. All right, so when you're only talking about def package, you're only talking about names. You're talking about names to symbol object instances at construction time, and that's it. You're not talking about any of the other associated things that would happen much later during the parsing phase. So as I mentioned, def package is what's used to create new packages. There are a bunch of options for this. In fact, some of these, I'll be honest, when I went into the CLHS just to see if there were additional options, I never saw a couple of them, primarily the size option. So let's just go through them one at a time. The first thing that you'll see here is, and I'll use this as my example here, is you have def package and the name of the symbol. You have a documentation string that sort of defines what this package is all about, much like every other documentation string that we've seen earlier on. You can also provide a set of aliases. Like you can have a full-length name for this package, but then people can use nicknames for these. These are your nicknames, a list of symbols that people can use to actually represent that package in a much more shorter form. So you can use a longer name that describes the package, and then you can have a nickname for that package as an alias so that people can leverage that name when they're calling functions from your external API. Then you have essentially a use string, which is listing the set of packages who you want their external symbols to be into the current package. You almost always, I've never heard of a case where you don't want to do this. You almost always want to use CL, because that's going to give you everything in the common Lisp package. I don't think you don't need to use CL user, because what CL user is when Lisp loads, okay, when any Lisp loads, UCL becomes a member of CL users package, and CL user is essentially a scratch package. And the reason why CL user was created is because you can't actually intern new symbols in CL. And that also means, and this is to Judd's point earlier, because Judd, you were asking why you couldn't actually do set symbol value on plus. You cannot modify, actually, at least my understanding, you cannot modify any of the symbols that are interned in the CL package. So
it's undefined behavior to modify symbols in the CL package. SBCL, though, is nice and implements this proposal called package locks, which does actually make it difficult to accidentally modify symbols in the CL package.
Okay, so hey Judd, were you using SBCL earlier?
Yes, I am.
Okay, yeah. That answers that question. Package locks. That's
yeah.
I didn't realize it was undefined before ever, but I'm pretty sure that you should not do it.
I know I shouldn't, but Elijah, you said it makes it difficult. Does that mean it's possible?
SBEXT without package locks.
Okay, thank you.
Don't though. It's actually a really bad idea.
It's not recommended.
Yeah, if you need something like that, you probably want to shadow a symbol.
Yeah.
So to add a symbol on top of one of the existing, you're basically replacing one of CL
Sure.
Symbol,
I just want to do like plus and have it come up with like 17 or something. Well, I'll give it a try.
Yeah, so what you would probably do there, as Michael was saying, is you would create your package. You would use the CL package, but you would shadow. I don't know if we talked about shadow yet.
We're just about to talk about shadow, and shadow
Yeah,
is
yeah.
there's two cases, right? What is a shadow? First off, shadowing basically the idea that the definition or the symbol instance is getting overwritten almost with a new symbol instance. So all references of that name will point to the new symbol instance instead of the old symbol instance. So there's two different cases on this. One is in defining a package, you have the notion of shadowing a symbol, meaning that the current package has already a new definition for that name, and it wants to use that instead of what's being defined in another third-party library. In which shadow is going to do is it's going to exclude that symbol from being imported from the third-party package that you're trying to import from. This is usually used in conjunction with use. And then shadowing import from, what it does is it takes whatever has been previously defined with this symbol and just overwrites it with the new symbol instance from that current package. So I have an example of this actually here. So here I defined a package with a function called hello world. In fact, let me just go ahead and compile this guy and load it because this is kind of important. So I have three packages. One basically defines a function called hello world. I have another package that also defines it, defines hello world, and then it adds like two additional functions, add and subtract. And then I have a package 3 that basically uses package 2, which means all the symbols from package 2, that is hello world, add, and subtract, are going to be added to it. And then I'm importing from package 1 mult, which means I'm selectively importing particular symbols from package 1. All right. Then this shadow import, which is what I was trying to come to, what this does is, since package 2 has hello world, I'm telling the package system, ignore the one that you just defined. I want to actually use this one from package 1. And we go ahead and I shadow sub, but what it does is it tells the Lisp reader, hey, I want you to exclude creating an entry in package 3 symbol table for subtract, because I'm not using that function at all. And then we define later on, subtract. So if we go in and change into package 3, and we call another function, you'll see that it's actually calling package 1 as we expect, package 1's hello world as we expect it. And you will see that if we call subtract, it actually calls package 3's subfunction because it created a new subtraction instance. I mean, this is a very basic example, but it sort of illustrates, what we've been discussing so far about shadowing. Did I miss anything, guys? Elijah, Michael?
No, not really. That basically covers it. I mean, you use shadow when some package you're using or importing from defines a symbol that you want to give a different meaning to, and you don't want to be mucking about with that package's version of the symbol.
Right.
Cool.
All right.
And shadowing import from, is when you specifically want to override, what package a symbol comes from.
What often happens, and this is actually, I'm glad Peter actually brought this up towards the end of it. When you first start getting into packages, shadowing is probably going to be one of the more tricky areas that you'll end up stumbling on if you actually use a lot of the same names in different packages, I guess. Primarily because you may not realize that you overrode a function, especially when you start programming significantly large systems. You may not realize that another package has defined um, uh, a function or an object associated with that particular name, and it got read in because you used the package and you overrode it. And now you have some subtle bug where it was expecting the previous package's implementation of that function or whatever, and now it can't find it. Um, that's usually one of the more trickier ones that people, at least I know I've stumbled on it when I first started learning packages. The more trivial one is often, and this is actually one of the reasons why I brought up about the discussion on symbols. When you first use a symbol and it's not defined, common Lisp complains, but what SBCL at least does, and I think almost all other common Lisps do the same thing, is they actually intern and create a new symbol for it in the symbol table. Now,
that's not quite how that's working. Just to stop you there.
All right.
It's not at the package level that's causing that issue.
It's at the. I thought it's at the reader level.
It's not at the reader level.
It's not at the reader level. Okay.
No, at the reader level, when the reader comes across a symbol it doesn't know about, it always interns it. There's no warning, no nothing. Reader always interns symbols.
I don't think so.
The issue is when you...
If I do X, and X is unbound, it's internal.
When you use a variable, right? So what it's complaining about there isn't the symbol X. It's complaining about the variable X. It's the evaluator that's complaining, not the parser.
Oh, okay. Gotcha.
So that's sort of an important distinction to make.
Okay.
You can have symbols that have no meaning in the runtime.
Okay. So what's happening is that it creates a new symbol instance, and now the evaluator hits it. It's like, okay, give me whatever's associated with the symbol value or symbol variable, and if it's not bound, it's going to complain about it because. But now at this point, X is already available. So if I just find a symbol, and it's a I keep forgetting it's a string. Sorry.
String, yeah.
Yes.
And capital S.
String.
Oh, Jesus.
This is why I like read.
Oh, jeez.
But yeah.
All right.
Yeah, so as you see, like it did in fact already create the symbol. The symbol exists. It's just if you then do, what is it? What's the function for checking if a symbol is bound?
Bound P.
Bound P.
Yeah, bound P.
Yeah, that's the one. Bound P. Well, symbol.
Yeah.
Yeah.
And it's nil. Right.
Right.
Okay.
And so it's an existing symbol, but it's not a variable.
It's an existing symbol, but it's not a variable, and it's not a function. So
correct. It's also not a function.
It's a blank symbol with no information from it. All right. So the reader, as far as the reader's concerned, you can make always blank symbols, but the evaluator starts complaining if there's no context information on their usage. So
correct.
All right. That makes me feel
the evaluator. The evaluator is what cares about the runtime nonsense, like whether or not a symbol actually is a variable or not. The reader doesn't care at all. The reader really is just a parser. It's just it's just a parser for a data structure. It doesn't care about any of the weird runtime nonsense, like what a function is.
Right. It populates the symbols. It's like a typical parser. It populates the symbol table, scoping tables. If it's scoping tables is actually, I guess, for lexical scoping.
The evaluator.
That's the evaluator. Yeah.
Yeah. Scoping is the evaluator.
It's the evaluator.
And actually, as an interesting side effect of this is that you can, and this is not something I ever recommend that people do, because it looks very weird and there's no reason. You can have local variables whose names are symbols from other packages. There are technically use cases for this involving macros, but in practice, you're never going to see somebody write, let symbol from other package be this thing. But you can, because the evaluator doesn't see packages. The evaluator just sees symbols.
Right.
The evaluator, all symbols are equal. All that matters is whether or not you can, call EQ on it, and it's the same actual identical symbol. All the evaluator cares about is the identity. Doesn't care about the name, doesn't care about the package, doesn't care about any of that.
So, in terms of compilation, just because
Yes.
this will be interesting, by the time it hits the evaluator, the idea should be that the evaluator already is aware of which symbol instance that it needs to do a lookup on, right? It doesn't have to run through the lookup at all. Like the names have already been substituted with the symbol instance.
It's actually better than that, because the evaluator, the evaluator doesn't even think about symbols, really. For example, let's have we played it all with the eval function?
I think we touched a little bit about it in the past, but I don't remember if we actually went through in detail about eval.
So this is probably as good a time as any to do a quick little run through of the eval function. It takes a data structure that represents some code, and it compiles and executes it, or at least it compiles and executes it on SPCF.
So if I do, it has to be a quoted expression, right? Yeah, original expression. Yeah.
Yeah.
Be a quoted expression.
Well,
so.
It doesn't have to be quoted. It just has to be a data structure. For example, you could say list.
Okay.
And then quote plus.
Quote plus.
Or even find symbol plus if you wanted.
Yeah, I'm not gonna go that fancy, but okay, I could do that. That's fine. We can do that. Find symbol plus
quotes.
Oh. Yeah. Jesus Christ. All right. Yep. I need to remember this. All right. And 1, 2, 3, and it will go ahead and it will evaluate this guy.
Yep.
Oh, interesting. Okay. So it will compile that too, right? So if I go and technically, I would hope I could do this.
No.
No, I cannot. All right.
What you can do is so disassemble takes a function. And disassembles a function. It doesn't take an expression.
Yeah, you have to wrap that in a lambda.
Yeah. And I'm not sure that would tell you much.
Probably not.
I'm kind of curious about it. That's all. Let's see what happens. Let's symbol. Oops.
A lot of x86.
Yeah, it is a lot of x86. But this actually brings up an interesting thing about how it's creating the generic code for the object, the Lisp object. That's particularly okay. That's a much more deeper discussion about Lisp compilation, which if people are interested, I'm willing to actually do a couple of talks on Lisp compilation. That's
that's not for today.
That's not for today.
What is important though, right, is you can let's have a little bit of fun. Create a local variable storing the plus symbol.
Like a def var or a
yeah.
Okay.
Def var x and find symbol plus.
All right. So now.
Yep.
I should be able to actually just use this directly, shouldn't I? Because it can do a lookup?
Yeah.
Yeah, I could do this. I think I could do this.
No.
I thought we could. Hold on. Because I did this once before. Hold on. I must be thinking about symbol function. I must have pointed it directly to symbol function. Right.
Right. Yeah.
If I do symbol function, I think if I do this, it will give me the lambda associated with it.
No, unfortunately.
Really?
Although I wish that you could do that. I wish that you could do that. But you can't actually put an arbitrary form at the start of an expression that evaluates to a function object, just because of a weird limitation in how the syntax works.
You're talking about like an anonymous function, right? Like I could do this.
Well, you can do that, yes, but you can't put you can't have the start of an expression be a call to symbol function.
Okay, gotcha.
Right. But yeah, you should have been able to call symbol function on that. Okay, what's the value in x? See that.
10? Why is it 10? Should have been...
That's weird. Yeah, what's find symbol... Oh, you already defined x as something.
I did?
Def var doesn't update existing symbols.
Def parameter. I thought I... Oh, right. Okay, hold on. Symbol plus. got to remember that. All right. Let me see.
Yep.
Okay. Now.
Yeah. Now, if you call symbol function there, that'll work.
Yes, that's right. Okay. So you sure I can't do this? Hold on, I'm kind of curious now. Let me see. Okay.
I very much wish you could, but you cannot.
You cannot.
I was gonna ask, is this some? I mean, I believe something like that can be done in Scheme.
Yes.
So
yes, you can do it in Scheme.
Valid in Scheme, because Scheme unifies it's not a Lisp 2, right?
Yeah.
And in principle, you could do something similar with Common Lisp, where if the start of a form was another list, it just evaluates that list. And I don't know why they didn't just do that.
Wait a second, though. Let me see now. If I do a make symbol,
we can do like what we can use apply or.
Oh yeah, could use apply, because you can pass a symbol to apply, and it'll call the F definition. No, you don't even need to do that actually, because if you pass a symbol to apply, it will actually look at the symbol function. That symbol.
You're like this.
Yeah. I don't recommend that you do that, but you can. That's.
Hold on. Am I supposed to put a list?
Right,
Hold
yeah,
on.
I need to give it an actual
You
list.
need to give the last argument as a list.
Oh.
Right.
All right.
Yeah, which is why fun call would have been a better example there.
Yeah.
But oh well.
Yeah, fun call would have been a better example. I should have gone with fun call. Let's see if this guy works. Yeah.
Yep.
Yeah. All right.
Yeah, and because that works, you should also be able to do fun call symbol function plus. Right?
Yes. Yes, you can. That
or
I
just
know
quoted
you can
plus.
do. I think I've seen that.
Just quoted plus. Well, no, that won't work.
This
Find some.
Ah.
Any of those things work. Yes.
Hold on. This one should work. I know that, right?
Yes, that will work.
All right.
Yes.
It works. All right.
Yes, but you can also just pass the quoted symbol to fun call.
Yeah, that one I know that you could do that. This one, you're talking about this? This?
Yes.
Okay, yeah.
And actually, that's the reason why passing the value of star x star works.
Right.
Because star x star holds the symbol plus, and so you're passing the symbol plus to fun call.
Right.
You know. And so my point, though, is in all of this,
and you
the
guys can
symbol
actually
is
query
just...
that. You can query that too as well, and you'll see that it's a symbol object.
Yeah.
It's not actually.
Yeah. Oh, I mean, type of a symbol. Yeah. Like the point is that through all of this, right, we're operating on the evaluation side of the whole symbol thing, right? And so what's important is the identity of the symbol, not its name. It doesn't matter that the plus symbol is named plus. It doesn't matter that it's in the CL package. It matters that its symbol function is the plus function.
Right.
You know, and so because of this, you can now do eval list star x star 1 2. Right, so you can get that list and you can eval it.
Yeah. Right.
You know, and what you've just done there is you've constructed a list starting with a symbol and followed by some arguments and passed it to the evaluator.
Right, and that's essentially what happens in the REPL. I mean, that's the same thing as creating your own dummy REPL. You know.
Yeah, you can do eval read.
Right. This one, I think we've actually done this in one of our previous broadcasts. But
Yeah.
Yep.
So you can do that and then just that.
Done.
But the point really is that, you know, the package management happens entirely in the read side of things.
Right, and that makes sense, and that's what that leads to something that was I think Michael and I were discussing earlier before we started, and that's the notion of well, how do you organize these packages, and essentially when you're really ultimately starting to create a fairly large Lisp project, what is the difference between, like, say, a package, a system, I think a library, and something another. A what now? A module. That's right.
Module, yeah.
Yeah. Yes.
That link in the chat is a good, quick little overview Edie Waits wrote about the difference between the three.
Yes.
Right.
And I posted this, guys, on. I hope I actually checked it in. If I haven't, I will check it in again. Okay, so I haven't checked in this updated version. But I posted all this information again in the GitHub repo. So if you guys want to actually grab this information, feel free to fork the GitHub repo from the Atlanta FP's main GitHub repository. Yeah, we have plenty of other examples too there as well from previous broadcasts for any newcomers that are watching this or on this channel right now. But it has a very good. I was reading this earlier actually, and it's interesting that I didn't realize that systems were not actually defined in
Not at all.
the standard. So that's interesting because for the longest time I always thought make def system was just part of the standard because I've seen it enough times before ASDIF came out. I was like, okay, it just exists. All right.
Systems are entirely a community agreed upon thing.
Hey, Ram, there's one quick point I want to bring up about defining your own packages.
Yeah, sure.
This is actually pretty important, and I think Elijah can agree due to past experience here. Package names are global to your whole entire Lisp image. Therefore, you should do some research, see what names are already taken, and when you're defining a package nickname, that too is also global. Don't define something like ABC, because if somebody else comes around and wants to use some software that also uses that package name, you're going to have major conflicts.
Yep.
Try to be distinct in your package names, both in your package name and your nickname that you give it, if you decide to give it a nickname.
So one question I actually have about that, because you brought it up, since packages are global. So Peter, in a lot of practical common Lisp, and I think even others have adopted this, sort of adopted the Java approach of creating like multiple modules.
Reverse domain notation.
Yes.
Yeah, I'm not a fan.
Okay, you're not a fan. Okay.
Same.
Gotcha. All right. So reverse domain. You don't. Do you believe that people should use this, or do you believe that?
No.
Okay.
Not really. No.
Very few people do. It's not really that common, and it actually gets pretty messy.
All right. Okay.
One thing, and this is getting a little more advanced, so we may want to talk about it in the future, or we could get into it now.
Can we go back for one second?
Oh, sure.
I have a quick question before we get too far ahead.
Sure.
When you said that, I got confused when we started dipping into a vowel line, because where does the name conflict come in if something's defined in another package already? What is doing that? What is saying oh, this is already defined in package X, and you're trying to define it in your current package?
So it's not so much trying to define something, because defining usually implies an evaluation level operation, right? When you get conflict messages, so there are two reasons why you might get name conflicts, and one of those is, as we mentioned earlier, when you try and modify a symbol that's in a locked package like the CL package. But that's an SBCL specific thing. There are a couple of other implementations that implement the whole package locks proposal, but that's an implementation specific thing when a symbol is protected in a sense because it's in a particular package. The other case where you'll get conflicts is when you use two packages and both of them define a symbol.
Right. That's the case I'm talking about.
Right. So, and that happens entirely when you define the package. When you're doing the def package operation, or later on, if you call use package, if your package, at any point in time is using or importing symbols from two different packages, and there are name conflicts at the symbol table level, that's when you'll get the error. And that has nothing to do with the values associated with those symbols. It entirely has to do with those symbols being associated with conflicting names in the
Right,
packages.
but is the reader?
Yeah.
Yes.
Well, the reader is what creates symbols. Really, it's the specifically it's the intern function that creates symbols, but the reader is the thing that's usually calling the intern function.
Hey, Elijah, sorry to interrupt. I think what Michael's asking is where does the error actually get triggered?
Yeah,
when...
because like the thing that's confusing me is right, like if the reader is reading in the symbols, right?
Yeah.
So let's say I have a package 1, and I'm in my current package is package 2, and
Sure.
in package 2 I'm using package 1.
Sure.
And in package 1 I have a symbol X.
Yes.
That has a function associated with it.
And you've exported that symbol.
Now in package 2 I got to do a def on X.
Yeah.
And something's going to go, hey, X
No,
is,
nothing will error. You'll actually overwrite the symbol defined by package 1. Or you'll overwrite the function defined by package 1. That will not error.
So then how come I get the error if I have a function that's already defined in the current package and then I import another package and it'll tell me that there's...
That's because that's not the function that's getting a conflict. What happens there is your package already defines a symbol by that name, right? In order to define something using that symbol, you had to have interned that symbol in the package. You have to have used the symbol in the package.
Right.
Later on, if you then proceed to use an additional package in your package, right, it will attempt to import all of the symbols from that parent package. And as it's going through importing all the exported symbols from that parent package, one of them will have the same name as the name of a symbol you've already used in your current package.
Okay, so what handles the importing? I'm assuming that's eval.
That's actually read. That's not actually eval. When you do a use package, it's a read. It's actually reading it.
No. So at this point, the distinction starts to break down between read and eval. What you're talking about now is the package manipulation functions. Packages are objects. They're objects in the runtime, right? They have an API for manipulating them. They're maintained by invariants in that API.
Right.
And so what's raising the error is one of the functions in the internals of the package system. And so it's when you call use. It's really the use function which is raising the error. And yes, technically speaking, you're evaluating some code that calls use, but that's not really because of the evaluator's use of the symbol tables. It's just you're calling that function. There's the some function that handles the process of manipulating the package system. So this is a case where that distinction stops being quite as useful because both read and eval are calling functions involving symbols. But neither of read is calling functions like intern, right, to add new symbols to packages in order to manipulate the package system. Eval is calling functions on the symbols themselves. It's calling things like symbol function and symbol value in order to look up things associated at runtime with those symbols. But then you're calling use, right?
That's what's confusing me because like I'm evaluating a function, obviously.
Right.
Use, but at the same time, it's like stuff involving the read table. So it sounds like this is kind of something that's like basically implementation dependent, like depending on how they handle the interplay between read and eval and how internally.
Somewhat, yes. I mean, part of it is that, as I said, packages are just objects. They're objects in the runtime. They aren't like read tables in the compiler somewhere, right? They're you can inspect a package object. Like Ram, if you don't mind actually doing that real fast.
Oh, you want me to? Okay, so hold on.
If you don't mind.
Yeah, that's fine. So you want me to do what again? So
inspect a package object.
Okay.
Actually hit enter on that package object there.
Got it.
Because you have a reference to that package object.
Yeah.
And
Enter.
you can,
Hold on. Control C, I, enter. No.
No, that won't work.
Only in slide.
Inspect.
I should be able to do inspect star, right?
Yeah,
That should
although I
work.
don't know. Yeah, that ought to work. I've never actually
That will
called the
work.
inspect function that way.
Okay, that works.
Yeah, that got you into the SBCL inspector.
Yes, it did.
That's abusive. Quit out of that. Use swank : inspect in Emacs.
All right. Swank.
Elijah, how do you know?
No. It's at the REPL. It's
Okay.
a Lisp function.
Swank.
Yeah. So.
Colon. Hold on. I think I have to quit out of the.
Yeah. No. Yeah. Q.
Q. Thank you. All right.
Q.
Swank. Colon. Inspect in Emacs. Jesus.
Yes. And star.
Star. Got it. All right.
Or maybe only star. We might only want star.
No, just-
Oh yeah, no, star. Yeah, there we are. So if you know that package table is just an object,
Yes.
right? It package 4 has a name. It has a list of other packages it uses. It has 978 symbols it inherited from the common Lisp package.
So this must mean that there is a set of package. Yeah, there is. Okay.
Yeah.
There's package accessors. It's a structure basically. It's a def struct.
A package is a structure.
Okay.
A package is an object in the runtime.
Okay. Go on. Just wanted to make sure. So it's much like anything else.
And so while you're right in some sense, yes, that is all internal stuff. It's also not really internal stuff, because the same APIs that the reader and the evaluator use to talk to things like symbols and to talk to things like packages, they're just functions that are exposed to the runtime and that you actually have access to as well.
So, Michael Gargano, I think I have to make sure there are two Michaels in this channel, so I have to make sure that I think the point is with at least with any Lisp development in general, right? Everything is an object that's accessible. There is an API associated with it. There are certain aspects that may not be as useful based on your situation, but in terms of packages and package management, you could certainly inspect and certainly look at the object instances, much like any other object that's running in your system.
Because and part of what it really is that eval doesn't actually look at packages ever. Eval itself, when it is evaluating code, and this is sort of really the point I was making earlier, is eval doesn't even know about the package manipulation API at all.
Right.
It's given symbol objects as part of the code that it takes in. The data structure representing the code that it takes in. It's given those symbol objects, and it calls the symbol APIs. It calls symbol value, it calls symbol function, or it calls something more efficient implemented by the internals that effectively does the same thing. But there's code in the runtime, right? Eval, in some ways, it is special because it has access to functions that aren't exposed any other way by the common Lisp package, right? But in other ways, it isn't really all that special. It is just a function. It can call the compiler, and the compiler is, implementation defined. The APIs for interacting with it are implementation defined, but you can call eval, and eval is just a function that knows how to invoke the compiler. Read is just a function that knows how to invoke the parsing mode,
right.
And you can actually implement your own reader if you wanted to. It's actually not very difficult. I mean, it's a little tricky because the read table is, really robust and able to handle all kinds of crazy nonsense. But in principle, the kinds of things you see in day-to-day Lisp code, you can actually re-implement the entire algorithm behind the reader yourself and just call out to the package API routines the same way that read would. And so, when you come across the text representation of a symbol, you capture that in a string and you call intern. And, intern handles talking to the package tables and, adding the new symbol to the package table if necessary, or just getting out the existing symbol by that name.
You can redefine the compiler, though, too, couldn't you? You could technically redefine the compiler, because that's just yet another function that you could replace. I'm not saying that you should. I'm just saying that it is possible because the entire
It
system
is
is live.
technically possible on SBCL to open up the compiler and redefine large parts of the internals at runtime. I've actually done this. It's kind of fun. It's really easy to break things.
But
I don't recommend it without a lot more. You can, in fact, like, you can get into all kinds of crazy nonsense if you start looking into things like def transform in the SBCL internals, which lets you generate new code based on existing code using the types of values after the compiler's done its type, propagation pass. And all kinds of crazy nonsense like that. You can change how SBCL generates the assembly to implement calls to particular functions.
But
so
I guess my question is
but that's not important. Yeah.
The only real question is that since it's a live system, right? Like the hyperspec doesn't actually say you can't, and I'm very that you can't do that. It's possible.
Correct.
And it's implementation specific as to whether or not they'll give you that ability, right? Really, like SBCL is able to do it. Closure CL, I think I was able to. You can also manipulate the Closure compiler too at runtime. I'm not sure about some of the commercial Lisps like LispWorks
I'm
or Allegro.
almost certain you can muck about with the compilers of the commercial Lisps. They probably even have well-documented APIs for it that they only give to people who pay them large amounts of money.
I don't know because I've never actually played it at that level. I'm just saying that
being able to manipulate the compiler to better suit the needs of your application is a very Lisp thing, right? Like, being able to manipulate the language, that way is a very, very Lisp thing to do. And I have no doubt that the commercial Lisp implementations are more than happy to support that kind of low-level trickery.
But the hyperspec actually does not forbid it. Is I guess my big question, right?
The hyperspec does not say pretty much anything about how the implementation should handle its own stuff. It's actually very liberal in that sense. Really, all the hyperspec does is define a set of APIs.
Right.
It defines a set of APIs that get exposed from the CL package, and it requires that you implement the debugger, the inspector, and the REPL. But that's pretty much it. The hyperspec doesn't define the quit function or the exit function.
Right.
At all.
It's funny. Those of you who are reading Practical Common Lisp today. Although back in 2006 that may be the case, but I think almost every CL implementation since this book has been published has implemented quit.
Oh yeah, I have trouble imagining that. Well, if not quit, at least there's either quit or there's exit.
So in Allegro, I know for a time, for a while, at least up until 2012, which is the last time I used commercial Allegro. To exit out of the Common Lisp REPL, you had to use :quit, which was a keyword that internally called their API to exit out of the thing, or :exit. But
I greatly dislike languages that make their REPL that special.
Hey, Ram, I posted a link for you in the chat about quit.
Portable exit.
Oh wow, that's amazing.
That's great.
Oh god. EXCL exit. That's amazing.
Oh man.
So you could do it. And anyway, so I guess to properly answer your question, Michael, is that it's not neither read nor eval are really what's doing the package manipulation at all. Neither of them are mucking about with the package. They're calling functions that muck about with the package, and then the same functions that are exposed to you. Read calls intern, like you can call intern. Eval calls symbol function and symbol value, like you can call symbol function and symbol value. Probably for efficiency's sake, there's something lower level in the way those are implemented that's not exactly that. But the behavior is supposed to be that there should be no observable difference to what read is doing and what you could do by calling the package APIs. And so, while read is taking the string representation of some code and turning it into the object representation using the package system, right? It's using the same APIs that you could be using to do that very same process. And so when the error gets raised from the package system, it's not really read that's raising the error or a val that's complaining. It's the functions inside the package system. If that makes any sense.
Mr. Gargano, did that answer your question?
Sort of.
Sort of. Let me come up with your actual question really is, at what point does a name conflict arise while you're playing around with the REPL? That's your actual question, right? I just want to make sure that
yeah, because in my mind, right, when if I have the package that I'm importing from, and I already have the symbol defined there with a function attached to it.
Yeah.
When I'm calling read in the current package that I'm in,
yes,
right, it sees that symbol and it's interning it, right, because it's just reading in symbols and that's all it's doing.
Yep.
But at some point, it notices that I'm calling defun, and it knows that that's a no-no or whatever,
It doesn't, actually.
No, I know, that's what you said, but
yeah.
I guess what I'm saying is when I call import, and it's already defined the other way, that's when it complains that there's a conflict.
Right. If you define something, it'll shadow it. But if you intern it and then try to do an import, it'll complain. I've seen that actually because that's
I know that's what BCL was doing when I was playing with it the other day.
Yeah.
So that's why I was confused. I'm assuming the reader just says, okay, here's a pointer to an intern symbol object. But I would assume that a val is the thing that's complaining, oh, you're trying to defund this thing and it's already...
No, a val doesn't actually complain about that at all.
Okay, so that is the reader then.
It is the reader.
Okay.
Not really the reader either.
What?
So let me actually show this, right?
Okay.
So create one package and have it export some symbol, and then I suppose you already have this, right? You have one package that exports a symbol and defines a function with that name.
Yes,
right?
I have a package that exports the symbol, package 4.
Okay.
Yeah. Okay.
Okay. Yeah. Now define a package 5 that imports that uses CL into package 4.
Okay. Package 5. Use CL in package 4. All right. And all right.
Now switch to package 5.
I may have to define package the function because I never actually defined the function.
Oh yeah. Before you do this, switch to package 4 and define hello world.
Yeah, that's what I'm gonna do. That's
yeah.
That's what I'm doing. All right. All right. There you go. Now we're going to package.
Okay. And actually, before you do that, redefine hello world to do something else.
Okay. Hello again. And return the sum of 3 numbers. All right. All right. Warning. Redefining.
Okay. Yep.
All right.
Yep.
So now I'm going to switch over.
That's the evaluator complaining just about some redefinition.
And
switch to package 5. And redefine the function again.
Define hello world. And this time I'll say hello from package 5. Okay. And it tells you that it's redefining it here again because we're using it.
Yeah, and now it's redefining package 4 hello world.
Yeah. If you notice that, Michael, it recognizes that you're using something from a different package, and it's warning you.
It's not that it's from a different package at all. It's just that you're redefining a function.
You're redefining a symbol that's already been read, right? I mean, that's what it is.
You're redefining the function value, the symbol function of a symbol. Right.
Okay. That's what you're doing. Yes.
That's the important thing. It's not about the symbols, right? It's about the symbol function of the symbol.
It's about the property symbol function, right? If you're thinking about it in objects, there's an instance variable there called function that's pointing to a function pointer that you're redefining, and the evaluator basically says you're overriding this member variable with this new definition, and it warns you about that before it's.
But my point is, if you know, it's the same warning whether or not you were redefining it when you were in package 4 versus when you were redefining it in package 5.
Right.
Because the evaluator doesn't see the packages; it just sees you have this symbol here, this hello world symbol, and you're redefining the function associated with it.
Right. Okay. So when because I know you did an example of the bug and I did play with it, and I forgot what I did now. There was something where SBCL prompts you because you have symbol conflict.
Yes. So in that case, let's define another package, package 6 that just uses CL.
Okay, give me a second. Let me go and change it. I guess I could do it here. All right, package 6. Use the CL. Got it. And
and now switch to that package.
Package 6. All right.
And define a function hello world. And before you hit enter, so note, at this point, there is no hello world symbol at all in package 6. But the moment that form gets read, there will now be a hello world symbol in package 6. And once the form gets evaluated, that symbol will be associated with some function object.
Right, so if I hit enter here,
it'll read and it evaluates.
It reads and evaluates, it creates a new symbol, it creates a new lambda because it recognizes that there's it's associated with
the creation of the symbol happens during read, and then the association of that symbol with the new value happens during evaluation. And note, there is no warning this time. But now, if you use package 4.
If you use package 4 : hello world.
No, just use package.
Okay. Use.
I mean, you can call it, but yeah, the whole point is use package.
Hold on a second. For some reason, complete mode kind of messed me up here. All right, use package 4. All right.
Yes. And now it'll error. And the reason is, package 4 exports a hello world symbol.
Right.
And you already have a hello world symbol defined in your package 6.
Right. So what's causing that message? That's really what my question is.
The call to use package.
Right. So is that happening during eval time? Is what I was.
Yes. Yes. That's happening during evaluation.
It actually gives you in a link directly to the hyperspec section that it complains about.
Which I find really amusing.
That's actually kind of interesting.
Because the hyperspec isn't the.
And there's a in the stack too. So.
A name conflict is said to occur.
Yeah. So this is during evaluation.
Right.
Yeah.
So that was my question, because you said that eval doesn't know anything about the package system.
Right.
So
it doesn't.
Right, so when it goes to import this or whatever,
eval's not what's doing the using. Here, let's make that a little more clear. Exit the debugger here.
Got it.
And do fun call. Actually, fun call. Hash quote use package 4.
Hash quote use package.
Hash quote.
Oh, sorry. Hash quote.
Sorry. If you do hash colon use package, it'll get very unhappy with you.
Sharp quote. All right.
Yeah.
Got
sharp quote use package. Package 4.
Package 4. All right. I think I have to put a keyword, right?
Yeah. Should be a keyword or a string.
Yeah. Got it.
Keyword's easier. Same error. It's, use package is just a function, right? You could store the use package function in a variable. You could define a function which calls use package 4 and call that.
Actually,
in fact,
let's
do that. Let's define a function foo.
Right. So I think so. Maybe I think we're just having a semantic thing here. So-
I think there is actually a way
Yeah.
of looking up what the use package actually does, doesn't it? Like I can actually go to the function
Yes.
definition.
I just meant that in terms of use package, like that error was being generated by whatever function was being called during evaluation, not during
Yes.
read time. So like I understand
Right.
use packages separate.
So my point was more that it's that there's a distinction between load time and runtime that we haven't really gotten into.
We almost got into that a couple of weeks ago, but that went right over my head.
So here let's define. Yeah. Let's define a function that calls use package. So define some foo.
Okay, foo uses, let's say, use
That
package.
calls use package.
Okay, use package and
Package.
let me say package 4 internally. All right.
Right.
Done. So
Now, the important point here is that the evaluator has already evaluated that entire function. It's evaluated the use package.
right.
It's loaded it into the runtime as compiled code. It hasn't run that code yet because it's in a lambda. This is the difference between load time and runtime. That code inside that function has been loaded, but it has not been run. So now if you call the function, it'll throw the error.
Right, and that's what.
And yeah, abort out of that.
All right.
And so you're right. It is sort of a semantic difference, but it is kind of important that it's not the evaluator itself that's doing the importing. It's the function you're calling.
Right. Yeah, I got that.
You know.
So basically, the load time and the runtime thing is basically down to whether or not it's like a top level evaluation versus
Yes.
obviously something in a lambda or
Actually, that's a very good distinction, I think. The top level evaluation versus a deferred evaluation in the case of calling the lambda directly.
Yeah. So eval sort of combines the tasks of loading and execution.
Right.
Right. Eval sort of it loads and it then executes. Right. But it just executes the top level forms. Any forms that are in lambdas, the bodies of those lambdas don't get executed unless those lambdas get called. It still loads the bodies of those lambdas so they can be executed in the future, but it hasn't actually executed them because you wouldn't want it to. You want to wait until the function actually gets called. And so that's really the distinction. It's that load time is when the code is being put into the runtime so it can be executed. And, and there's actually even further subdivisions from there. There's compile time versus load time versus execute time, but that's another day entirely.
Yeah.
It feels like this when I feel like I'm never going to win this thing.
Well, really, what it is compile time is for caching. It does all the macro expansion. It can do some pre-optimization steps, and on some implementations, it actually generates the machine code at that phase, and then it can actually save that out to what's called a fast load file. You might have seen FASLs sometimes, FASL. These are fast load files. So you can call what's called compile file. And you can give it a Lisp file, and it'll generate, it'll expand all the macros, it'll compile the code, and it'll dump that out as a pre-compiled version of that file. And so there are some things that happen after parsing, but before loading into the runtime, and those are the things that are involved in compiling. And so you have parsing, which is done by read, and then you have compiling, and then loading, and then executing. And compile, load, execute, eval does all three all at once, but you can actually separate them out if you need to. That's really all that is. There's some bits of oddness there, but for the most part, it's not actually that weird. It's just about being able to cache the caching time to time spent compiling the code.
I think this has been a very good discussion because this honestly is an often. I've never
Yeah.
had a real good. I'll be honest. When I first learned this, it was very difficult to really understand. I had to go through different books to really come up with a pretty decent understanding of how packages
To be honest,
work. So
it wouldn't hurt, honestly, just to dedicate one of our sessions to walking through the life cycle of Common Lisp code in the runtime.
that's that's an excellent idea. I will.
Just like walking through, and that might be something we introduce ASDIF at that point as well. We actually introduce systems at that point. Probably
Right.
wouldn't be a bad idea. It's because we actually walk through how ASDIF figures out what files to load, how it actually goes about compiling and loading, and all the ordering nonsense, and when things happen, and how you control when things happen, and all that craziness.
So, so here's a proposal. Maybe we should, because next week we're on essentially the last real chapter in the book, which is on loop, which is itself a huge discussion.
Yeah,
that's a few weeks.
Yeah, loop might take us a little while.
So I think before we touch base on loop, because loop I want to also touch iterate too as well, because honestly, if we're going to go through loop, we may as well go through iterate, just because a lot of more folks have been recommending using iterate anyway over loop. Maybe we should touch base next week on ASDIF and systems, because it's a step above. Unfortunately,
yeah, we are overtime now.
No, we are overtime today, definitely. But it's been a great discussion, folks. Thanks a lot for holding on to this really enthralling thing. We can keep going, but we had a time study group, and I'm going to try to hold to that. Join us next week.
I will do my darndest to be here by 5:30.
I think next week we'll get started on talking about ASDIF and systems. This is something that's not in the book, and we'll give you a good tour of what exactly it takes to create a proper, Common Lisp system. Preparing it for
getting into ASDIF and getting into the actual life cycle of loading and compiling and all that stuff, because it's important to know, and it's not something that's documented in a lot of places terribly well, in my opinion.
I will give an announcement on this. I'm trying to work through this still, but I'm trying to come up with a deployment talk on this, just because, especially with Roswell, I think it's a good time to discuss how to actually set up deployments for executables, even set up things for, like, if you want to use Docker, for example, for creating web applications and posting them on Google Cloud Platform. But that's coming talks. Loop itself is very, very, very involved, and we don't have time for that.
Yeah.
So
it's not actually, Loop's individual components are not actually very complicated. It just has so many of them.
Right. It's a very involved chapter. Let's just say that. And when you really start learning about Loop, and then you have to bring up, how do you extend it? And that's where, I think Loop kind of breaks down. And that's where iterate sort of steps in. So we have a lot more coming into, but, we're out of time.
Iterate is basically the Swiss Army knife of all kinds of iteration and looping.
Right.
I've pulled nonsense off with iterate that almost makes me cry. Anyway, yeah.
So until next time, folks.
I think a lot of the confusion, Mike, that you're having with this language will definitely be cleared up once we get to actually implementing a simple piece of software.
Yeah.
Start to finish.
Yeah, and that's
that really good.
It's not the. I mean, I've been looking at this for a long time, so I understand.
Well, I hear where you're coming from.
But there's a lot of little details that are just.
Yeah, I've been using the language for over a decade now, and I probably barely scratched the surface, to tell you the truth. It's a complex language. That's because it exposes so much to you. You can implement the compiler yourself, just like Elijah was talking about.
I think Tim Daly said it best. Common Lisp has been a studied language for such a long time, but there's so much to learn that you could spend an additional decade just to go through it. And he said it in response to someone talking about, well, why did Clojure sort of come to being? He's like, well, Lisp has this, this ability to always eat its young. So if you want to bring it in, just keep bringing it in. And the language sort of grew over time. And what we're seeing, at least with Common Lisp, is an amalgamation of a finite set of different Lisp that sort of came together, into
Yeah.
into what you see today. And
what is nice about Common Lisp is you don't actually need to understand all of it in order to use it effectively.
right,
Absolutely. Yep.
and that's I think the real.
Do a lot.
Yeah. So until next time, folks. This has been a great discussion. I hope the guys who watch this hope you guys enjoy this good back and forth that we're having here. Any requests that you guys want for talks, please either contact me or other folks on Discord. I'll be on Discord usually, or I'm on the Functional Programming Slack channel, as well as meetup.com. Please join Atlanta Functional Programming. We will certainly take your notes and feedback and really try to bring in more quality material over time. Thanks for joining us. I'll see you guys next time.
Okay, thanks a lot, Ron and Go Stars. Appreciate it.
Thanks.